In 1981, inside a Michigan assembly plant, General Motors quietly discontinued the true Pontiac V8. The final motor wasn't a tire-smoking powerhouse, but the 301 cubic inch V8, a compromised block built to survive an emissions era that no longer tolerated traditional muscle. The collapse had become painfully public just 4 years earlier. In 1977, buyers opened the hoods of their new Pontiacs and found Chevrolet engines bolted between the fenders, triggering class action lawsuits over a corporate consolidation strategy that replaced engineering pride with shared parts. The cost fell on the people who trusted the iron. Mechanics lost an engine they could tune by sound. Street racers lost a unique, single-block architecture that could swallow massive crankshafts without demanding a heavier outer casting. Factory workers lost the lines that gave their town its identity. The very torque that made the Pontiac V8 an American icon had become its fatal flaw under strict fuel economy mandates. But the real story of the Pontiac V8 is not only how a production line stopped in 1981, it is the story of how a single piece of cast iron taught America what horsepower felt like. And what happened when Detroit decided that kind of identity was too expensive to keep. Every week we tell the stories of American engines, factories, machines, and industrial names that once taught the country what power sounded like and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in Detroit, Michigan, in 1955. In 1954, the American highway system was rapidly expanding. The post-war economic boom had created a new kind of consumer, speed limits were climbing, and General Motors was dominating the automotive landscape. But inside the corporate hierarchy of Detroit, GM had a serious problem with one of its oldest and most profitable divisions. Pontiac was dying of boredom. The General Motors ladder was strictly structured. Chevrolet was the affordable car for the working man. Oldsmobile was the technologically advanced car for the middle-class manager. And Cadillac was the ultimate reward for the executive. Pontiac was supposed to sit just above Chevrolet, a step up in prestige, comfort, and power. Instead, it had earned a fatal reputation across the country. It was widely known as an old man's car. It was heavy, it was overbuilt, it was reliable, but it was agonizingly slow, designed for a conservative generation that had survived the Great Depression and had already stopped buying new cars. The source of this mechanical depression was bolted beneath the hood of models like the Pontiac Chieftain. While competitors were innovating, Pontiac was still relying on a relic of the 1930s, the flathead straight 8 engine. A flathead is an engine design where the valves sit down inside the heavy iron block alongside the pistons, rather than up in the cylinder head. In a rural 1930s farm town, a flathead straight 8 was a perfectly logical machine. It was simple to manufacture, it idled quietly, and it could run forever at low speeds. But in the booming high-speed traffic of the 1950s, a flathead literally choked itself. Because the fuel and air had to make sharp, restrictive 90-degree turns to get into the combustion chamber, the engine simply could not breathe enough to produce high horsepower, a measurement of how quickly an engine can do work at higher RPMs. When American drivers pulled out to pass a semi-truck on a 2-lane highway, the old heavy iron straight 8 gasped for air, generating a lot of heat but very little forward momentum. Pontiac engineers, working out of their massive foundries and drafting rooms in Pontiac, Michigan, knew they needed a V8, an 8-cylinder engine with cylinders arranged in 2 banks in a V shape. Sister divisions, Cadillac and Oldsmobile, had already revolutionized the industry by introducing modern overhead valve V8s back in 1949. An overhead valve, or OHV design, places the valves in the cylinder head directly above the pistons, operated by long metal push rods. This architecture allows air and fuel to flow in a much straighter, more efficient path down into the cylinders, letting the engine breathe deeply, spin faster, and generate the kind of aggressive, immediate acceleration that 1950s American buyers suddenly demanded. In 1955, after years of secret development, Pontiac finally delivered its answer to the dealership floors, the 287 cubic inch Strato-Streak V8. The launch of the 287 fundamentally altered the trajectory of the division. It immediately produced 180 horsepower, a massive leap over the tired old straight 8. Suddenly, a Pontiac sedan could merge onto a modern freeway with authority. It sounded completely different, replacing the quiet hum of the flathead with the sharp, aggressive, mechanical idle of a modern V8. But what made the 1955 Strato-Streak a true milestone in American industrial history was not just its initial horsepower rating. It was the brilliant, hidden architectural secret cast into the iron itself. When an automaker designs an engine, the foundation is the block, the main heavy iron structure that holds the cylinders, the spinning crankshaft, and all the major internal moving parts. In most automotive empires, engineers build completely different blocks for different needs. Chevrolet, for example, would eventually create a lightweight small block for standard cars and a massive, physically larger big block for heavy trucks and extreme muscle cars. If an American mechanic wanted to swap a Chevy big block into a small block car, they had to deal with a nightmare of different engine mounts, heavier front suspension springs, and cramped, impossible engine bays. Pontiac engineers took a completely different, highly efficient path. They designed a single, incredibly robust block architecture. From that first 287 cubic inch engine in 1955 all the way to the massive 455 cubic inch monsters of the 1970s, the external dimensions of the Pontiac V8 remain virtually identical. To understand why this mattered on the street, you have to look at how displacement, the total volume swept by the pistons inside the cylinders, is calculated. To make an engine bigger and more powerful, you can either increase the bore, which is the diameter of the cylinder hole, or you can increase the stroke, which is how far the piston travels up and down on the crankshaft. Pontiac engineers realized their original 1955 block casting was so strong and had so much extra thick iron cast between the cylinder walls that they could simply machine larger bores and install longer stroke crankshafts inside the exact same external package for the next 25 years. A mechanic could place a 1955 287 block next to a 1970 455 block on a shop floor, and externally they look like twins. In an American garage, this single block design was a mechanical revelation. It meant that years later, a teenager could pull a tired, low-horsepower 287 out of a rusty 1955 sedan, drag a massive 400 cubic inch V8 out of a salvage yard, and drop it straight onto the original factory engine mounts. The transmission bell housing would bolt right up. The exhaust manifolds would fit. The timing covers, water pumps, and distributors were entirely interchangeable. Without realizing it, Pontiac had accidentally created the ultimate plug-and-play power system for the American hot rodder. But in 1955, the street racers at local drag strips were not yet paying full attention. The 287 was a strong, reliable start, but it was still bolted into cars that featured excessive chrome and styling that looked like it belonged to a retired bank manager. That disconnect changed permanently in 1956 when a new general manager named Simon "Bunky" Knudsen took over the struggling division. Knudsen looked at the declining sales figures, walked into the design studio, ordered the signature silver streak stripped off the hoods, and famously declared that you could sell an old man a young man's car, but you could never sell a young man an old man's car. He ordered his engineers to stop focusing on mere reliability and take Pontiac racing. To win on the banked dirt and asphalt oval tracks of NASCAR and the flat concrete strips of the NHRA, the engine had to grow. Because of the brilliant single-block architecture, it was cheap, fast, and easy for the factory to scale up the power. By 1956, the foundry increased the bore and stroke to push the engine to 316 cubic inches. By 1957, it grew again to 347 cubic inches, powering the newly introduced fuel-injected Pontiac Bonneville. The engineers began experimenting with high-performance camshafts, the rotating shafts that control exactly when the engine's valves open and close to let fuel in and exhaust out. They strengthened the connecting rods, the vital steel links that transfer the explosive downward force from the pistons directly to the crankshaft. Dealership parts counters across the country quietly began offering specialized, heavy-duty performance components right out of the catalog. Mechanics in independent repair shops started to realize that the Pontiac V8 was not just a reliable daily driver, it was massively overbuilt. It could handle brutal compression ratios and massive amounts of fuel without breaking the block. By the end of the 1950s, the old straight eight was a distant, forgotten memory. The division's sales were rapidly recovering, and the iron foundation was fully established. Pontiac had successfully cured its identity crisis, transforming its engineering culture from cautious, slow reliability to aggressive mechanical ambition. The engine had proven it could change a reputation. It had not yet proven it could dominate a culture. By 1959, the single-block architecture had evolved into the 389 cubic inch V8. This specific displacement would become the foundation of Pontiac's performance reputation, but iron alone was not enough to capture the American youth market. To dominate the street, the engine needed a way to breathe massive amounts of fuel and air. The engineering division's solution was the legendary tri-power system. The tri-power was a specialized induction setup that used three two-barrel carburetors bolted in a row across the top of the intake manifold. A carburetor is a mechanical device that mixes liquid fuel and air into a combustible vapor before that mixture enters the engine cylinders. In the 1950s and early 1960s, most standard American cars used a single, economical two-barrel carburetor. High-performance models might use a single, larger four-barrel. Pontiac engineers decided to give the driver a mechanical split personality. Under normal driving conditions, a Pontiac 389 equipped with tri-power ran solely on the center carburetor. It was polite, relatively efficient, and behaved perfectly when a driver was navigating slow-moving suburban traffic or pulling into a grocery store parking lot. But the outer two carburetors were connected to a progressive mechanical linkage. When a driver on a rural highway or an open stretch of Woodward Avenue in Detroit pushed the accelerator pedal to the floor, the linkage snapped open the secondary carburetors. Suddenly, the engine was breathing through all six barrels. The sound changed instantly from a quiet exhaust hum to a deep, aggressive mechanical roar, flooding the massive cylinders with fuel and throwing the heavy car forward. In American garages, the tri-power became a cultural obsession. Tuning it required patience, a good ear, and a flathead screwdriver to synchronize the throttle linkages. When it was dialed in correctly, it was nearly unbeatable on the street. But the true breakthrough for the Pontiac V8 was not just a fuel system, it was an act of corporate rebellion. In early 1963, General Motors executives grew terrified of potential government antitrust regulations and liability lawsuits surrounding automotive safety. In a sweeping corporate edict, GM management officially banned all of its divisions from participating in factory-backed auto racing. For Chevrolet, this was a setback. For Pontiac, which had just spent the last 7 years convincing the American public that it built aggressive, race-winning machines, the ban was a death sentence. If Pontiac could no longer prove its engineering superiority on the banked ovals of NASCAR or the sanctioned drag strips of the NHRA, the brand's identity would collapse. A rogue team of Pontiac engineers, led by John DeLorean, Bill Collins, and engine specialist Russ G., realized that if they could not take their engines to the racetrack, they would have to bring the racetrack to the street. At the time, General Motors had a strict corporate rule regarding its midsize cars, like the Pontiac Tempest. Management dictated that these lighter, smaller cars could not carry an engine larger than 330 cubic inches. The massive 389 cubic inch V8 was strictly reserved for heavy, full-size luxury cruisers. But DeLorean and his team found a loophole. The corporate limit applied to standard, base model production cars. It did not explicitly apply to optional equipment packages. In the fall of 1963, Pontiac offered a $295 option code on the midsize Tempest. If a buyer checked that box on the dealership order form, the factory would drop the massive 389 V8, producing up to 348 horsepower with a tri-power setup, straight into the lightweight chassis. They called the package the GTO. This simple, unauthorized combination of a heavy-duty engine in a mid-size car fundamentally invented the American muscle car. The physical feeling of the 389 V8 was entirely different from its corporate rival, the Chevrolet small block. Chevrolet had built an empire on high RPM horsepower. Pontiac built its empire on torque, the raw, twisting force that a driver feels as the pulling strength of an engine right off the line. Because of its massive heavy block, long stroke, and heavy internal rotating assembly, a Pontiac V8 did not need to spin to a screaming 6,000 revolutions per minute to make power. When a driver dropped the clutch at a stoplight, the 389 produced a violent wave of low-end torque that immediately overwhelmed the rear tires and pushed the passengers deep into their seats. The demand was instantaneous. Pontiac sales executives had cautiously predicted they might sell 5,000 GTOs in the first year. Instead, American dealerships were overwhelmed, moving over 32,000 units. Dealerships could not keep them on the lot. Young buyers were walking into showrooms, ignoring the chrome-laden luxury sedans, and heading straight for the parts counter to ask about heavy-duty camshafts and limited-slip differentials. The breakthrough extended beyond the factory floor. The Pontiac V8 became a complete self-sustaining mechanical ecosystem. Independent dealerships realized that the factory was leaving power on the table to appease corporate management. One specific dealership in Michigan, Royal Pontiac, became legendary. Royal Pontiac offered specialized tuning packages called Royal Bobcat kits. A buyer could order a new Pontiac V8, and the dealership mechanics would install thinner head gaskets to increase compression, the squeezing of the air-fuel mixture inside the cylinder before combustion, which forces a more violent explosion. They would recurve the distributor for better ignition timing and install larger carburetor jets. By the mid-1960s, the automotive press was obsessed. Car and Driver magazine famously tested a tuned Pontiac GTO against a Ferrari, cementing the 389 V8 as a working-class hero. The single-block architecture had transitioned from a clever manufacturing trick into a nationwide performance platform. Mechanics loved it because it was predictable and overbuilt. Street racers loved it because it survived brutal abuse. Dealerships loved it because the performance halos sold thousands of ordinary cars to buyers who just wanted a piece of the magic. The formula was perfected and the iron was ready. The streets of America were about to find out exactly what Detroit engineering pride sounded like. By the late 1960s, the American horsepower war had escalated into a brutal, factory-funded arms race. Ford was pushing its massive Cobra jet blocks onto the street. Chrysler was unleashing the legendary 426 Hemi. To survive, an automaker could not just be fast. It had to be constantly, violently evolving. But Pontiac had a distinct industrial advantage. They did not need to spend millions of dollars designing an entirely new heavy engine block to fight back. They just needed to machine bigger holes in the incredibly strong iron they already had. The expansion had actually begun quietly a few years earlier, hidden in the specialized parts catalogs of the early 1960s. Pontiac engineers had pushed the single-block architecture out to 421 cubic inches for the legendary Super Duty program. The 421 Super Duty was not a polite street engine. It was a purpose-built racing machine sold over the parts counter to NHRA drag racers and NASCAR teams. It featured forged internal components, massive cylinder heads that allowed massive amounts of air to flow into the engine, and dual four-barrel carburetors. It proved to the American mechanic that the original 1955 block casting was almost indestructible. By 1967, General Motors finally lifted its internal corporate ban on putting engines larger than 330 cubic inches into mid-size cars. Pontiac immediately capitalized. The foundry in Pontiac, Michigan, retooled the block once again, standardizing the street performance engine at a massive 400 cubic inches. This engine would become the absolute backbone of the division's golden era, powering everything from heavy Bonneville luxury cruisers to the newly introduced Firebird pony car and the fearsome GTO. To understand the scale of this empire, you have to look at the physical reality of Woodward Avenue in Detroit during this era. Woodward was not a sanctioned racetrack. It was a massive, multi-lane public road lined with drive-in restaurants, gas stations, and stoplights. On a Friday night, the air was thick with the sharp, sweet smell of high-octane, leaded gasoline and the aggressive, metallic clatter of solid lifter camshafts. Dealership mechanics, factory engineers, and teenagers brought their machines here to test exactly what the foundries had built. The Pontiac 400 V8 commanded immense respect on this street because of how it delivered its power. It relied on a heavy cast-iron crankshaft and long connecting rods to generate brutal, immediate low-end torque. When a driver launched from a stoplight, the heavy front end of a GTO would violently lift, pressing the rear tires hard into the asphalt. To feed this larger 400 cubic inch engine, engineers introduced the ram air system. Ram air was a functional induction setup that used open scoops on the steel hood to capture cold, dense air rushing over the front of the moving car and force it directly into a sealed carburetor box. Cold air is significantly denser than hot engine bay air, meaning it holds more oxygen molecules. When a carburetor mixes more oxygen with more gasoline, the resulting explosion inside the cylinder is vastly more powerful. By the time the Ram Aero full version of the 400 engine was released in 1969, the factory claimed it produced 370 horsepower, a number that most mechanics knew was deliberately understated to avoid terrifying the insurance companies that were beginning to crack down on young drivers. This was the absolute peak of American mechanical trust. In an America where an engine could decide whether a field was cut, a truck made its delivery, a boat left the dock, a generator carried a hospital through a storm, or a machine commanded the street, power was not an abstraction. It was iron, fuel, labor, heat, sound, repair, and trust. The ecosystem supporting the Pontiac V8 was massive and entirely self-sustaining. Independent machine shops across the Midwest were buying bare Pontiac blocks and rebuilding them for local drag strips. Parts catalogs from aftermarket companies like Edelbrock and Hooker Headers featured pages dedicated exclusively to the Pontiac architecture. Dealerships like Royal Pontiac in Michigan and Myrtle Motors in New York were running specialized performance clinics, teaching young buyers how to adjust their valve clearances and rejet their carburetors for maximum speed. The engine was no longer just a product built by General Motors. It was a physical identity owned by the people who drove it. But the street demanded even more, and the engineers were preparing one final, massive expansion of the iron. In 1970, General Motors officially lifted its final, self-imposed restriction on engine size for all passenger cars. The foundries in Michigan responded by pushing the original 1955 single-block architecture to its absolute physical limit. They bored the cylinders and lengthened the stroke one last time, creating the massive 455 cubic inch V8. At 455 cubic inches, the engine was displacing nearly 7.5 liters. The iron walls between the cylinders were now incredibly thin, representing the maximum expansion the block could safely handle without losing its structural integrity. This engine was not designed to scream at high RPMs on a racetrack. It was built to dominate the raw, stoplight-to-stoplight reality of the American street. In its most aggressive early configurations, the 455 produced an earth-moving 500 pound-feet of torque. In a rural American town, that level of torque fundamentally changed what a car could do. When bolted into a heavy, luxurious Pontiac Grand Prix, the 455 allowed a massive steel cruiser to pass a convoy of commercial trucks on a two-lane highway with barely a push of the throttle. When dropped into a GTO, it created a vehicle so aggressive that insurance companies began raising premiums to impossible levels or outright refusing to write policies for young drivers. But the true peak of the Pontiac V8, the moment that cemented its legacy in the American garage forever, came a few years later in an act of absolute corporate defiance. By 1973, the golden era of the American muscle car was supposed to be over. The federal government had passed the Clean Air Act, mandating strict new emissions standards. The looming transition to low-octane, unleaded gasoline forced engineers across Detroit to drastically lower engine compression. Ford's massive Cobra jets and Chrysler's legendary Hemis were rapidly disappearing from dealership order forms. The industry was retreating. A small rogue group of Pontiac engineers refused to surrender. Working under the radar of GM's upper management, they released the Super Duty 455, or SD 455, for the 1973 and 1974 Firebird Trans Am. The SD 455 was a street engine in name only. It was a thinly disguised racing power plant. Engineers cast the block with reinforced lifter galleys. They installed massive, high-flow, round-port cylinder heads to maximize the amount of air the engine could breathe, and they used heavy-duty forged steel connecting rods to withstand brutal internal forces. The block even featured physical provisions for a dry sump oiling system, a highly specialized technology used almost exclusively in professional motorsport to prevent oil starvation during high-speed cornering. In the service bays of American Pontiac dealerships, mechanics realized exactly what the factory had done. While the rest of Detroit was building choked, low-performance motors to appease the regulators, Pontiac had secretly pushed a hand-assembled race engine past the corporate auditors. The factory officially rated the SD4555 at 310 net horsepower. Every mechanic with a dynamometer knew that number was a deliberate lie designed to keep insurance agents calm. The engine was easily capable of producing well over 370 horsepower, making the 1973 Trans Am the last true, uncompromised muscle car standing on the American highway. This was the pinnacle of the single-block ecosystem. A hot rodder could walk into a salvage yard in 1975, find a wrecked SD455 Firebird, unbolt the massive engine, and drop it directly into a rusted 10-year-old Pontiac Tempest without ever needing to change the factory motor mounts. The aftermarket was flooded with camshafts, intake manifolds, and high-performance carburetors specifically designed for the Pontiac architecture. Drag strips across the country were dominated by independent racers running Pontiacs, entirely because the block was cheap, ubiquitous, and virtually indestructible. For nearly 2 decades, the formula had been perfect. The foundry poured the iron, the engineers optimized the airflow, the dealers sold the attitude, and the American driver commanded the torque. Pontiac had built an empire not just on marketing, but on a piece of metal that mechanics inherently trusted. The engine had reached its absolute physical peak, but the sheer size of the 455, the exact massive displacement that had allowed Pontiac to dominate the street, was about to become an impossible liability in a world governed by the EPA, global oil shocks, and corporate accountants. The long decline of the Pontiac V8 did not begin with the final factory shutdown in 1981, and it did not start with a dramatic mechanical failure on the street. The first small crack in the empire appeared as a quiet corporate mandate issued from General Motors headquarters in 1970, taking effect for the 1971 model year. GM ordered all of its automotive divisions to drastically lower engine compression ratios across their entire lineups in preparation for the looming arrival of low-lead and unleaded gasoline. Compression, the squeezing of the air and fuel mixture inside the cylinder before combustion, was the absolute lifeblood of Pontiac's legendary torque. High compression created violent, powerful explosions, but high compression also required high-octane leaded fuel to prevent the engine from knocking, a destructive condition where the fuel detonates prematurely under pressure. In an American gas station in 1971, the writing was on the wall. The era of cheap, high-octane premium gas was ending. By enlarging the combustion chambers in the cylinder heads to lower the compression, Pontiac engineers instantly bled the raw power out of their brilliant single-block architecture. This shift was driven by a force that would rewrite the entire American automotive industry: regulation, emissions, fuel economy, and certification. The federal government had established the Environmental Protection Agency and passed the Clean Air Act of 1970. Detroit was suddenly facing strict, non-negotiable federal mandates that dictated exactly what could come out of a vehicle's tailpipe. To meet these new standards, engines would soon need a catalytic converter, an exhaust device installed under the car that helps convert harmful gases, like unburned hydrocarbons and carbon monoxide, into less harmful emissions. The exact architecture that had made Pontiac dominant, the massive long-stroke displacement of the 455 cubic inch V8, now became an absolute engineering nightmare. A massive cylinder bore burning large amounts of fuel inherently creates massive amounts of emissions. To get the 455 to pass federal certification, engineers had to systematically strangle their own creation. They installed highly restrictive intake manifolds. They retarded the ignition timing, which delayed the spark to burn the fuel cooler, but robbed the engine of its crisp throttle response. They fitted carburetors calibrated so lean that the engines often stumbled, hesitated, and stalled right off the dealership showroom floor. The numerical drop in power was staggering, exacerbated by an industry-wide change in how power was calculated. In 1972, American automakers shifted from gross horsepower ratings, measured on a stand with no accessories, to net ratings, which measured the engine with the alternator, water pump, and restrictive factory exhaust attached. The psychological blow to the American muscle car buyer was severe. A Pontiac 455 that had boasted a conservative 370 gross horsepower in 1970 was officially reduced to an embarrassing 200 net horsepower by 1975. In the service bays of Pontiac dealerships across the country, mechanics were facing a crisis of trust. Frustrated buyers were bringing in brand new Firebird Trans Ams and Grand Prix luxury cruisers, complaining that the heavy cars felt sluggish and unresponsive. The mechanics who had spent the 1960s tweaking carburetors and advancing timing to maximize speed were now legally forbidden from tampering with the new emission systems to restore the lost power. The American garage culture, which had treated the Pontiac block as a blank canvas for horsepower, was suddenly criminalized by federal anti-tampering laws. Compounding the regulatory pressure was another massive market shift: fuel, oil, supply chains, and energy shocks. In the fall of 1973, the OPEC oil embargo sent gasoline prices skyrocketing and created nationwide fuel shortages. The sight of American drivers idling their cars in miles-long lines at gas stations permanently altered the consumer mindset. A heavy cast-iron Pontiac 455 V8 that struggled to achieve 10 miles per gallon was no longer viewed as a symbol of highway freedom. It was a severe financial liability. Families began looking for smaller, lighter, and more efficient vehicles, shrinking the market for massive displacement engines almost overnight. Pontiac engineers tried desperately to adapt. They shifted their focus back to the smaller displacements of their single-block architecture, relying heavily on the 350 and the 400 cubic inch versions to power their cars. But even the 400 was struggling to breathe through the new, restrictive, pellet-style catalytic converters. The massive torque that had defined the brand was slowly evaporating. By the end of 1976, the mighty 455 cubic inch V8 was officially discontinued, quietly dropped from the factory order forms. The biggest iron was dead. Behind the scenes, a much larger systemic threat was gathering. Pontiac was bleeding engineering resources trying to force an aging, heavy 1950s block architecture to meet stringent 1980s emissions and fuel economy targets. General Motors' upper management looked at the corporate balance sheets and saw massive inefficiency. Why were Chevrolet, Pontiac, Oldsmobile, and Buick all casting, machining, and assembling their own completely unique V8 engines? To the corporate accountants, a V8 engine was just a generic power unit, a standardized part that could be shared to save millions of dollars in manufacturing costs. To the American mechanic, however, the difference between a high-revving Chevy small block and a torque-heavy Pontiac 400 was a matter of mechanical religion, factory identity, and garage loyalty. But the bean counters did not care about torque curves or street racing heritage. They cared about survival in a recessionary economy. The Pontiac V8 was being slowly suffocated by the federal rulebook and the changing economics of American fuel. But the fatal blow would not come from the government. It would come from the corporate boardrooms inside General Motors itself. In the spring of 1977, the slow erosion of the Pontiac V8 suddenly became a nationwide scandal. Across America, buyers were walking into dealerships and paying a premium for new Pontiac Firebirds, Le Mans sedans, and Oldsmobile Delta 88s, believing they were purchasing the distinct, heavy-duty engineering those brands were famous for. But when mechanics and owners opened the hoods to perform basic maintenance, they noticed something completely wrong. The valve covers did not have the familiar, wide Pontiac or Oldsmobile shapes. The oil filters were in the wrong location. The exhaust manifolds looked completely different. Without telling the public, General Motors had quietly begun dropping 350 cubic inch Chevrolet small block V8s into Pontiac and Oldsmobile cars on the assembly line. GM executives defended the move as a simple matter of logistics. The corporation was struggling to build enough emissions-compliant Pontiac and Oldsmobile blocks to meet demand, while the Chevrolet engine plants had excess capacity. To the corporate boardroom, a V8 engine was just a generic pump that burned gasoline, a corporate part that could be freely swapped between brands to save time and money. To the American consumer, it was outright betrayal. The resulting outrage triggered massive class action lawsuits, forcing General Motors to send letters of apology to thousands of owners and offer financial settlements or vehicle buybacks. But the deeper damage was permanent. The lawsuits proved that the era of distinct, independent engine engineering within Detroit was dying. The badge on the hood was no longer a guarantee of what was cast into the engine block. Corporate consolidation, the merging and sharing of parts to the point where individual brand identity disappears, was rapidly replacing industrial pride. Desperate to save their own engine manufacturing lines in Michigan, Pontiac engineers made one final, agonizing attempt to adapt their legendary architecture to the new era. In 1977, they introduced the 301 cubic inch V8. For the first time since 1955, the factory fundamentally altered the external dimensions of the block. To meet strict new federal corporate average fuel economy, CAFE standards, the engineers had to reduce the physical weight of the engine. They lowered the deck height, the distance from the spinning crankshaft to the top of the cylinder block. They cast the cylinder walls incredibly thin. They removed the heavy, durable counterweights from the crankshaft. The 301 V8 succeeded in its primary goal. It weighed over 100 pounds less than the legendary 400 cubic inch block, and it helped Pontiac meet federal fuel economy mandates. But in the process, the factory destroyed the exact mechanical trait that had made the engine an American icon. In the garages and machine shops of the Midwest, mechanics quickly realized that the 301 was completely hollow. It was structurally weak. If a young hot rodder tried to install a larger carburetor, a high-lift camshaft, or increase the compression, the block could literally crack under the stress, or the lightened crankshaft would fail. The engine that had spent 2 decades proving it was indestructible was now fragile. It could barely produce 140 net horsepower. The final gasp of the Pontiac engine empire arrived in 1980 with the release of the 301 Turbo, bolted into the Firebird Trans Am. A turbocharger is a mechanical device driven by hot exhaust gases that forces pressurized, dense air back into the engine, attempting to create the massive power of a large engine using a smaller block. On paper, it sounded like the future. In the physical reality of a 1980 American highway, it was a tragedy. Engineers were trying to force modern turbocharging technology onto a weakened, thin-wall 1950s block architecture, all while using a crude, traditional carburetor to manage the fuel. Under heavy acceleration, the engine was prone to severe detonation, a highly destructive condition where the fuel explodes violently and prematurely. To prevent the engines from destroying themselves before the warranty expired, the factory installed primitive electronic knock sensors that drastically retarded the ignition timing the moment the engine sensed pressure. When a driver pushed the accelerator to the floor, the 301 Turbo hesitated, gasped, and fought its own computer systems, ultimately producing a dismal 210 horsepower. It was a machine that looked like a street brawler, but ran like a compromised, heavily regulated appliance. The corporate executives in Detroit had seen enough. Producing a unique, expensive, emissions-choked engine for just one brand no longer made financial sense. The decision was handed down from General Motors headquarters. In 1981, the Pontiac engine assembly plant built its final V8. The casting molds that had birthed the 389, the 400, and the legendary 455 were retired. The factory lines in Michigan that had defined the American muscle car era were shut down, retooled, or abandoned. From 1982 onward, if an American buyer ordered a Pontiac Firebird with a V8 engine, they were buying a Chevrolet engine. The machine still ran. The compression dropped. The rules tightened. The corporate accountants took control. The assembly line stopped. The tooling was scrapped. The sound faded. The badge remained. The soul of the machine was gone. General Motors survived the emissions era, but the Pontiac brand never truly recovered its mechanical soul. For the next 3 decades, Pontiac vehicles were powered by corporate engines, mostly standard Chevrolet V8s, corporate V6, and 4 cylinders. The cars still wore the famous Arrowhead badge on the hood, but the unique heartbeat was gone. The division had been effectively reduced from an independent engineering powerhouse to a standardized marketing label. Finally, in 2010, following a massive federal bailout and a brutal corporate bankruptcy restructuring, General Motors officially shut down the Pontiac car brand forever. The company was dead. The corporate entity had failed, but the iron it left behind refused to die. In the ecosystem of American engine preservation, the death of a corporation rarely means the death of the machine. Today, the single-block Pontiac V8 survives in one of the most dedicated, fiercely independent enthusiast communities in the country. Because the original factory block was so massively overbuilt, tens of thousands of them survived the salvage yards. Go to any major American automotive swap meet, like the massive gatherings in Carlisle, Pennsylvania, or the local drag strips across the Midwest, and you will still find mechanics trading heavily weathered Pontiac blocks, timing covers, and oil-stained service manuals. But the legacy goes far beyond mere preservation. The demand for the Pontiac V8 remains so strong that independent American aftermarket companies eventually stepped in to do what General Motors refused to do. Specialized machine shops and engine builders, like Butler Performance, realized that hot rodders still crave the massive, low-end torque of the 400 and 455 cubic inch engines. When the supply of original factory iron blocks began to dry up, the aftermarket took a radical step. They began casting brand new, modernized Pontiac V8 blocks out of high-strength aftermarket iron and lightweight aluminum. Today, you can buy a completely new Pontiac engine, displacing over 500 cubic inches and producing massive horsepower, decades after the original factory was torn down. The physical landscape where this empire was forged has largely been erased from the map. The massive foundries and engine assembly lines in Pontiac, Michigan, facilities that once employed thousands of local workers and gave an entire American town its identity, were steadily shut down, abandoned, and eventually demolished. Today, parts of that historic General Motors footprint have been paved over to create modern testing facilities in private garage spaces. The ground where the 308-9 Tri-Power was born no longer produces any engines at all. Yet there is a bitter, surprise footnote to this industrial history. In 1997, General Motors revolutionized the modern automotive world with the introduction of the Gen 3 LS V8 engine. The absolute genius of the LS platform was its single, scalable external architecture, a single block design that could be manufactured cheaply, but bored and stroked to power everything from lightweight sports cars to heavy-duty trucks. It was celebrated as a corporate masterpiece of efficiency. It was, ironically, the exact same single-block engineering philosophy that Pontiac engineers had pioneered in 1955, and the exact same philosophy that GM accountants had killed in 1981 because they believed it was too expensive to maintain. The survival of the Pontiac V8 in the modern American garage is not merely nostalgia. Nostalgia is just a fond memory of the 1960s. A cast-iron Pontiac 455 being lowered into a chassis today is a physical argument. It is living proof of a time when an American automotive division built its identity on the actual metal it machined, rather than the marketing campaigns it funded. It proves that an engine was not just a disposable corporate part, but a foundational machine that tied the factory worker, the dealership mechanic, and the driver into a single system of mechanical trust. The industry decided that this kind of unique, heavy-duty architecture was too inefficient for the modern world. The rule book, the fuel pumps, and the accountants demanded standardization. But the people who turned wrenches in American garages never forgot what that specific torque felt like. Somewhere in an American machine shop, a heavy cast-iron Pontiac block still sits secured to a steel engine stand. The block has been bored out, the oversized pistons are ready, and the metallic blue paint is curing under the fluorescent lights, waiting for a Saturday morning where the machine will run again, long after the empire that built it disappeared. See you in the next one.